Hello student, good morning. Today I am going to start overlapping of atomic orbitals. Last class I have discussed orbital overlapping concept, directional properties of bonds. Now I am continuing overlapping of atomic orbitals. When orbitals of two atoms come close to form bond, their overlap may be positive, negative or zero depending upon the atom. This depending upon the phase or sign and direction of orientation of amplitude of orbital wave function. Positive and negative sign on boundary surface diagram. Just it can be sent by video. It will show by photo. You can see the sign phase of orbital wave function, and now after seeing the photo you can understand the overlapping. Already last class I have sent some photographs. Now you can see there also same type of things you will find. Despite that I will try to send other you can say photos which can show the overlapping. Here important thing is that this when two atoms will come close to each other, when they will come close to form bond, their overlap may be positive, negative or zero depending upon the sign or phase and direction of orientation of amplitude of orbital's wave function. Orbitals forming bond should have same sign. This is important things. Orbitals forming bond should have same sign, means phase, and orientation in a space, means same orientation, same sign, or you can tell same phase. This is called positive overlap. Now just this photograph, if you will see, then you will understand very clearly. I will send some photograph in video. The criterion of overlap as the main factor for the formation of covalent bond applies uniformly to homonuclear or heteronuclear or both. Homonuclear, heteronuclear, diatomic molecules and polyatomic molecules. It applies to all. We know that shapes of CH4, NH3, H2O molecules are tetrahedral, pyramidal and bent respectively. Already I have discussed. It would be therefore interesting to use valence bond theory to find out if these geometrical shapes can be explained in terms of the orbital overlap. Now this shape you are knowing, I have discussed. Then this can be explained. Geometrical shape can be also explained in terms of orbital overlap. Let us first consider the methane, CH4, that is the methane molecule. The electronic configuration of carbon in its ground state is, methane, it has a carbon atomic number 6. Then its electronic configuration will be there. You can write like this: 1s square, 2s square, 2p2. It means in outermost orbit, 4 electrons are there. You can write like this. Again I am telling you, 6 are there. Then 1s square, 2s square, 2p2. 1s square, 2s square, 2p2. Outermost 4 electrons are there. Then that electron configuration you can write in a simple way also, that helium electronic configuration you can write, and means a noble gas. Helium is a noble gas, and after that you can write directly 2s2, 2p2. And when carbon will be next, this is the normal condition. In a ground state, I have told you that electronic configuration of helium, and after that 2s square, 2p2. But this you can write in excited state. When carbon will be in excited state, then its electronic configuration will be helium 2s1, 2px1, 2py1, correct, and 2pz1, 2px1, 2py1, 2pz1. Means by getting the energy, they will come in excited state, and now their electronic configuration in this way you can write like outermost I am talking about 2s1, 2px1, 2py1, 2pz1. Means now it became, you can say, in 4 orbitals. Now it in excited state there are 4 orbitals. Okay, that this 2s electron, actually there was 2 electron in normal condition, that now that electron and 2p2 electron, both has 2 electron. Now after getting energy in excited state, both electrons from the 2s, electron from the 2p, they jumped and a new orbital opened. That is the this things 2py, 2pz. You can write for this extra. Now in everywhere, now it became only one electron. In 2s1, in 2px1, 2py1, 2pz1. Everywhere 1. Then now all are, you can say, unpaired. All 4 orbitals are unpaired. Hence now it can combine. Now it can combine with 4 hydrogen. Each hydrogen have 1 unpaired electron. Hence now they can combine with these 4 orbitals, 2s1, 2px1, 2py1 and 2pz1. They will, each hydrogen will overlap. One hydrogen will overlap with 2s1, other will overlap with 2px1, and third will 2py1, and fourth will 2pz, and 4 bond will be formed. 4 bond will be formed due to overlapping. Correct? This is the important things I have told you. The energy required for this excitation is compensated by release of energy due to overlap between the orbitals of carbon and the hydrogen. Okay. The 4 atomic orbitals of carbon each with an unpaired electron can overlap with 1s orbital of the 4 hydrogen atoms, which are also singly occupied. This will result in the formation of 4 CH bonds. It will, however, be observed that while the 3 p orbitals of carbon are at very important things I am telling you now, it will, however, be observed that while the 3 p orbitals of carbon are at 90 degree to one another, the HCH angle for this will also be 90 degree because they are attached with carbon. Then 3 orbitals are 3 p orbitals px, py, pz are at 90 degree and with each hydrogen, and all means all 3 hydrogens are attached to the carbon, hence obviously their angle will be also 90 degree. That is, their CH bonds will be oriented at 90 degree to one another. The 2s orbital of carbon, and the 1s orbital of H are spherically symmetrical and they can overlap in any direction. S orbital is, you know that it is spherical. That's why the 2s orbital of carbon and the 1s orbital of H are spherically symmetrical and they can overlap in any direction. Therefore, the direction of the 4th CH bond cannot be ascertained. It cannot be found out. The description, this description does not fit in with the tetrahedral means HCH angles of 109.5 degree. You see, this what I have told you, according to that, it should not be 109.5 degree. Clearly, it follows that simple atomic orbital overlap does not account for the directional characteristics of bonds to in CH4. It is telling about 90 degree, and by this arrangement you can't tell its angle should be 109.5 degree. Then clearly it shows that the simple atomic orbital overlap does not account for the directional characteristics of bonds in methane. Using similar procedure and argument, it will be seen, or it can be seen in case of ammonia and H2O molecules. The HNH and HOH angles should be 90 degrees. In a normal way, in NH3 and H2O, the HNH means hydrogen, nitrogen, hydrogen. That is the V-shaped I told you, na? This H2O V-shaped. HNH and H2O, in that bond should be 90 degree in a normal condition, but it is not 90 degree. This is a disagreement with the actual bond angles of 107 degree and 104.5 degree in NH3 and H2O molecules respectively. Actually it is 107 degree and 104.5 degree in NH3 and H2O respectively. But theoretically, simply in a normal condition, it should have been 90 degree, but it is 107 degree and 104.5 degree. That's why it means some things are there that normal arrangement, it will not work here. We have to understand overlapping of atomic orbitals. Okay. Actually, its reason already I have told you. That is in advance I told you, but by the overlapping we can understand the atomic overlapping, concept of atomic overlapping, we can understand the actual shape. Now, types of overlapping and nature of covalent bonds. Now you can understand. In diagram, by the diagram it will be clear. Okay, that as for example, these two orbitals px and px, they will overlap axis wise or end on or head on. Okay, three terms are used for the same: end on or axis wise or head on. Both will overlap. Px, px. This is called positive sign, or you can say in phase, overlapping in phase. Okay, both are in x-axis. Okay, direction will be the same. That's why they will overlap. After overlapping, whatever is in space, when both will overlap, then in the middle where both are common place will be there, in that both electron will be there. Both shared electron will come in the middle of the, you can say, common. When they will overlap, then in that space only electron will be there. Like that way, P orbital and S orbital can overlap, and both one electron will come in the sharing portion. Like that way, you can say py, they can overlap. Okay, py, they can overlap. And one other overlapping will be sidewise overlapping. Sidewise overlapping, also called lateral overlapping, means both are suppose vertical. Then if they will come closer, then obviously lobes will come closer to each other. Up lobes, down lobes, both will come closer, and there will be again common place in upper lobe also, lower lobe also. These lobes are actually electrons cloud. It will be just like a dumbbell. Okay, that type of a structure will be there, 50% up, 50% down. Then this shape is due to the electrons cloud. Electrons are found in this shape. Their movement will be in this shape only. That's why in dumbbell, sometime in a sphere, and the S orbital have a spherical shape, and P have dumbbell shape. Then this dumbbell shape, they will come close. When X will come in the PX, P orbital, 2 P orbital, when they will come, they will overlap. Okay, like that way, when Py will come, then again they will, orbital will touch, not the electron, they will just overlap, and common space will be there after overlapping, common place, then in that electron will be there. Then this is called Py overlapping. Like that way, PZ will overlap, may will come to parallel. In Py and PZ overlapping, both orbital will come in a parallel. Okay, then Py, vertical complete 90 degree will be there. Py, both orbital will come in a 90 degree vertical, and Pz they will come in a lateral, but lateral then it is not fully 90 degree, then they can also overlap. Then this I told you 3 type of overlapping: Px, Py, Pz, Pz, and purpose is same. After the overlapping, they will make the bond. They will make the bond. That's why all 3 bond will be different. They will make little bond will be little different. And this Px, that is the axis wise, Px, head on overlapping or end on overlapping, end overlapping. And this Px, Py, but what I told you, for this sidewise overlapping means vertical way or lateral way, when they will overlap, then that is called these things, that is also overlapping, sidewise overlapping, that is called sidewise overlapping or lateral overlapping. Okay, then now this I told you, all are in a positive, positive sign or phase, same phase, positive phase or same phase. Bond forms due to positive, when they will be in positive phase. Means same phase, positive sign or same phase. Phase should be same. And I told you zero overlap means here again you can understand negative overlap. Negative overlap means that will be not in the same direction, opposite direction. Dumbbell is there, then where electrons are there, two p orbital will be there. Then in one p orbital, electron will be there, suppose upside, and generally upside only electron will be there, down lobe no electron. Then if both you can say dumbbell will come in such a way that lobe where electrons are there, only that lobe should come in overlap to each other. Both lobes in dumbbell orbital, that 50% up, 50% down. Then upside electron will be there, not the down. Then like that way, when both orbital will come in such a way that both electrons should come closer, only then they will overlap, bond will form. Not like that, that one lobe have electron and other lobe have no electron. Then there will be no bond formation. That is called a negative overlapping, or negative, you can say negative sign, or you can say out of phase, because one lobe has electron, other lobe has no electron. Then how bond will be formed? No sharing, no overlapping, no sharing of electron. That is called negative sign or out of phase. Okay, phase means both lobes should have electron, then they will come in contact. That is called positive. And when one have electron and other orbital lobes have no electron, and they are coming close, then there will be no overlapping. That is called negative sign or out of phase. Then it is possible, this is also another condition. Then in that way there will be no overlapping and so no bond formation. Then third thing, that is zero overlapping. Zero overlapping means you can tell if both are not able to overlap, conditions are different. Just like you can tell p and p orbital and s s both are overlapping, but they can't overlap. They can't overlap in both, means upper lobe and down lobe. If they are touching, then there will be zero overlap. That is called zero overlap. Okay, and if they are far also, then zero overlap. Orbitals are far to each other, then also zero overlap. And if they are touching with down where there is no electron, then again zero overlap. Now I am going to discuss some very important terms, that is the types of overlapping and nature of covalent bond. This is very important. The covalent bond may be classified into two types depending upon the types of overlapping. Actually, covalent bond, you know that one I have not discussed, that you should know. In covalent bond, that is, concept is different. One coordinate bond is there, coordinate bond. In that coordinate bond, actually, you know that to make a bond, 2 electrons is required. Then covalent bond is formed due to the sharing of electron, equal sharing. But in coordination bond, what will happen? That is also a type of covalent bond only, but it is under that that has a separate, separate classification. Then here in coordinate bond, what happens? Both electron will be shared by only one atom. Both electron will be shared by only one atom, and sign of arrow will be there. Sign of arrow will be there. To whom it is giving, in that direction sign will be there. Then that type of bond will be called coordinate bond. Coordinate bond. I am giving one example. In that 3 bonds are available. This question is asked in almost medical, IIT and UPSC exam also. Okay, because this is rare example I am telling you. In that you will find all 3 types of bonds. You will find covalent bond, ionic bond, coordinate bond. Then what is that example? Then example is ammonium chloride molecule. In ammonium chloride molecule, all 3 types of bond you will find. You will tell how, then understand. Just imagine ammonia. Ammonia structure, 3 bonds are there. NH, NH, NH. And on nitrogen, lone pair is there, one lone pair. On nitrogen, one lone pair is there, and 3 covalent bonds are there. NH, NH, NH. Then now you can see nitrogen has a lone pair of electron. Then now when HCl will come, then HCl, you know that is a ionic bond. HCl is ionic bond. Then in HCl, electron of hydrogen that is given to chlorine. Chlorine has taken that electron and it becomes Cl minus. And now with hydrogen no electron is there, but charge is H plus. That's why HCl is formed, ionic bond. Now H has no electron, only positive charge is there, and Cl has one negative. Then now when HCl will come with near the ammonia, ammonia gas, then what will happen? Nitrogen has a lone pair of electron. That 2 electron will be given to H, which has no electron. In HCl, H has no electron. Then this nitrogen will give its lone pair of electron to hydrogen, and one arrow sign will be given. That's why now a structure became like this. NH3 will be there, NHH covalent bond, and near the lone pair electron that HCl will come. Then that lone pair electron will be given to H and sign of arrow, one arrow sign will be given, and then you can write HCl. Then now you can see all three this form will become molecule form will be now NH3 and HCl is there, NH4Cl, ammonium chloride. Then you can see here all three type of bonds are there. Lone pair given to hydrogen, lone pair given to hydrogen of HCl, and that is a coordinate bond. Then now all three bonds are present in ammonium chloride. Covalent bond, NH3 bond, that is a covalent bond, and lone pair electron given to H of HCl, then coordinate bond, and H and Cl ionic bond. This is the example I have given you, in that all three bonds are present. This question is asked. Okay, now I am telling you other things, types of overlapping and nature of covalent bonds. The covalent bond may be classified into two types containing depending upon the types of overlapping. According to the types of overlapping, I am talking about, I can say, covalent bond may be classified into two types depending upon the types of overlapping. First type is sigma bond, and second type is pi bond. Okay, sigma bond, its symbol is just like a 0, 6, no, 6 you are writing, like that type of a small sign with there. You can write like just like a 6. That is a sigma bond. And pi bond, pi you know, that is pi. Then two type of bonds are there, covalent bond, sigma bond and pi bond. Then what is the sigma bond? Then this type of covalent bond is formed by the end to end or head-on overlap, okay, or axis wise. This type of covalent bond is formed by the end to end overlap or head-on collision, also you can tell, head-on collision or head-on overlapping of bond, or head-on overlapping of bonding orbitals along the internuclear axis. This is called as head-on overlap or axial overlapping. Then sigma bond is formed due to axial overlapping or end to end overlapping or head-on overlapping. All are the same. This is called as head-on overlap or axial overlap, because overlapping will be more, that will be more the overlapping, more the strong bond. This can be formed by any one of the, you can say, so many examples are there. I will give you example. That first overlapping, S overlapping means spherical, s orbital, both will overlap. This is just like you are writing a ball like that, or symbol is just like a 0, spherical. Then both have one electron, hence both will overlap. And after overlapping, one new thing is there, means s orbital plus s orbital, both will mix and one common place will be there. In that both electron will come. That is called overlapping. Then this is called SS overlapping. And after overlapping, that little shape will change. Okay. Now this I told you, SS orbital overlapping means both both orbitals will overlap and they will come very close and they will make new orbital, and that is called actually that new orbital have little minor change, and that is called SS overlapping. Means two orbitals are making one orbital now. Two orbitals, S orbitals, are making now one orbital after overlapping. Okay, and this will have 2 electrons. Like that way, S and P second in that is called sp overlapping. SS overlapping I told you, now sp overlapping. Here S orbital and p orbital both will overlap. Then S is a spherical and p is dumbbell. Then both have one electron. S orbital plus p orbital both will overlap, and after that they will make sp overlapping. Same way, common place will be there, space, there both electron will come. Means S and one lobe of the P, 2 lobes are there. Then one lobe where electrons are there, that will overlap with S, and they will make only one orbital, that is called sp overlapping. Sp orbital, that is called sp overlapping or sp orbital. Okay, that is called only one. After overlapping, they will make only one orbital, sp. Like that way, pp overlapping will be there. pp overlapping means 2 p orbital will overlap, and both are in the same direction, means positive. Already told you, both will p orbital plus p orbital, they will overlap and they will give again same way new orbital they will give. In new orbital where both are overlapping, in that space both electron will be there, and this is again after pp orbital, they after mixing they will give only one orbital which will have 2 electron, that is called pp overlapping. Now come to the pi bond. In the formation of pi bond, already I told you in the beginning only, same things are here. In the formation of pi bond, the atomic orbitals overlap in such a way that their axes remain parallel to each other and perpendicular to the internuclear axis. Both will come in parallel, but automatically it will be perpendicular to the internuclear axis. Okay. Then the orbitals formed due to the sidewise overlapping, this is also called sidewise overlapping, means overlapping in such a way that their axes remains parallel to each other and perpendicular to the internuclear axis. The orbitals formed due to sidewise overlapping consist of two saucer type charged cloud above and below the plane of participating atoms. Saucer type, what I told you, lobe, that is called saucer types. Okay, lobe, upper lobe, lower lobe, A, lobe, E. Here also you can tell lobe is also called saucer, SAUCER, saucer type charged cloud shape, because sometimes electron will be upside, sometimes electron will be down. Upper lobe, lower lobe, in both places it will go, but bond will form only when both lobes having electrons are there. Both lobes have electron, both lobes have electrons, only then bond will form, that is a positive sign. Okay, then here this in pi bond, it is that due to the sidewise overlapping, or in this case their axes remains parallel to each other. Okay. Then after the overlapping, they will make a bond. They will make a bond. That bond is called pi bond. Pi bond. Okay. And this pi bond is bigger bond than sigma bond. Sigma bond is stronger than pi bond. Actually, in sidewise overlapping will be very less, not more. I told you, more the overlapping, more the strong bond. But here overlapping is less because sidewise overlapping is there. They are not overlapping too much. Very less overlapping is there. Both are parallel. That's why this bond is weak bond, weaker than sigma. Sigma bond is stronger. Sigma bond is stronger than pi bond. But whenever multiple bond will be there, means double bond and triple bond, then one bond will be pi bond, and other bond will be sigma bond. This is again important things I am telling you. Whenever multiple bond will be there, like ethylene or acetylene. Ethylene means double bond, then one bond pi bond, other sigma bond, and acetylene triple bonds are there, then one bond is pi bond, two bonds are sigma bond. Okay, between the two I am talking about. Then now I am going to discuss a strength of sigma bond and pi bonds. Already I have told you, but again you just understand. Basically the strength of a bond depends upon the extent of overlapping. In case of sigma bond, the overlapping of orbitals take place to a larger extent. Hence it is stronger as compared to the pi bond, where the extent of overlapping occurs to a smaller extent. Again, further, it is important to know that in the formation of a multiple bonds between the two atoms of a molecule, pi bond is formed in addition to a sigma bond. Okay, then today, now I am stopping only here. Next class I will start hybridization. Thank you.